Alright, good morning. We're continuing 10.2. Let's quickly go over what we did yesterday. Oh, Wednesday. We learned how to flip a prison into a power. I mean, technically a radical into an exponential expression. You have a radical here with index n. What does it turn into? Or vice versa, sometimes you have an exponential, you need to make it into radical. How do you do that? We basically did the red part, red direction a lot. So we always had an exponential, we turned them into exponent. First we worked on questions which have only one in the numerator, and then later we investigated what happens if you have a numerator on the top other than 1, 2, -3 or -4, and we just extended our description into cover numerators with m. You either put them inside the radical or outside, but I said I prefer this way. We put the numerator above the exponent, only the denominator is actually going away into the index, like a guard of the prison. And I also mentioned what to do if you have a negative sign. Really, what do we do if you have a negative sign? How do we cure negative signs? What do we do? Flip it, yes. We take 25 in the denominator under 1 with the opposite sign, positive 3/2. And then we change this into prison by 2. 25 cube. 25 cube means 25 triple times, and we each took each prisoner out by taking square root of 25. What number makes 25 and multiply? It was 555, and that was it. Alright, now we did that with even now we did the backwards thing. We have a prison. How do you change this into an exponential? The idea is the same. You put the number inside to the top, you put the number outside to the bottom, and you're all set. Okay? Alright, and we just figured that you may have more prisons and you may have more exponential expressions coming together. How do you combine them and make one exponential expression, such as if you have two separate exponential functions multiplying each other, like x to the 1/3 and x to the 4/3? The rule says you simply add the tops, like x squared times x cubed. You have double x and triple x. How many in total? 5x. You add them, right? So it's the same deal. 5/3, 1/3, 4/3. I explained these yesterday. I showed all these examples. We were about to apply this into a problem, and this is our first one. All you need to do is associate the question into one or more of the rules. Sometimes you just do the question solution with one rule. Sometimes you combine a couple of rules. So which one on this list? 1 through 5, and then we have 2 more. These are general previous observations. You already used them before. This wasn't new. But out of first 5, which one do you think we are going to use to make this question? I have a base raised into exponent, another base w, same base raised into another exponent, and they want us to combine them into a single expression. Simplify it and write your answer in using positive exponents only. That's second part. But how do you simplify this? How do you bring them into one, basically? We add the exponents, right? So it's 1/3 add -4/3. Okay? So can I add negative exponents? Yes, you can. It looks like you can add only positive, but who said m and n are always positive? It can be any rational numbers, including negative whole numbers, m and n. So we have one negative, one positive whole numbers. We are adding them. So you just need to take a separate spot here and add them. 1/3 plus minus 4/3. Or actually plus minus, some people like to combine these. Addition of a negative number is actually subtraction. You can combine plus minus into minus, but it's no harm if you keep it plus minus 4. You add 1 plus minus 4. Since they are the same denominator, you don't have to worry about matching the denominators. What is 1 plus minus 4? 1 take away 4. In other words, it's negative 3. And simplify that as much as possible. Negative 3 divided by 3 is negative 1. So that's it. We're done, right? So let's type this in. And first, shocking news of the day. This is incorrect. Why? We did everything according to the rule. We added them, canceled, and minus 1. Did I make a mistake here anyway?
Positive.
It's supposed to be positive exponents. The second half of the question is rewrite your answer so that your answer does not have any negative exponents. This one has one. So how do I flip this? Turns into 1 over W with the opposite sign, positive 1, but positive first power is the same as the base. You don't have to show that, so it's 1 over W. So we back this up and call this 1 over W. Okay? So, which rule have we used here? This is rule number 1. Two same base, different exponents. Keep the base the same, add the exponents, simplified, all that. Rule number 2. I'm sorry, question number 2, next question. Which rule are we going to apply in the list? Which one does it look like? Does it look like multiplication of two exponents? Yep, dividing like bases situation happen here. A-M-A-N. What's the rule say? Put a minus between those two bases. Keep that base the same, T. Just put those numbers on the top and subtract them. Well, you better do it on a separate side and then come back and replace here, okay? Well, good news with these questions is they are considered easy because they already have the same denominator, share the same denominator. All you gotta do is subtract the tops and simplify. You're all set. T to the first is the same as T. Alright? If you know the rule, it's a 30-second question. Alright. Which rule is this called? Let's look at the situation. This I call double power. They call just the power rule, but I call it double power because there is a power and outside a second power, double power. So how do I combine them? It's very tempting to say, oh, if I have two powers, they join. So I join them by addition. People just like adding them. It's intuitive. It's tempting. But this is wrong. Don't add them. Instead, what do we do with them? What's the operation between M and N? Multiply them. Wrong. Simply multiply. Well, this is 6 over 3, and 3 goes into 6 twice. This is 2. Or you could have just cancel it here. 1 times 2 is 2. Now this is another 20-second questions if you know the rule. Q squared. Any questions? Alright, which rule is this one?
You have to do. You do one and then the second one.
All right. There are multiple ways you can approach this question. Chris' idea is okay. You can first combine this by rule number 1. Look, it says if you have AA separate bases, you can combine them by 1 and then apply, you will have a single base with a power and extra power, double power. Apply rule number 3. 1 and then 3 works. Or you can do that, or what else can I do? Try to use a new rule. How about this? Can I do this here? Can I? Just think this giant A and giant B. Just ignore their powers. This is a giant A, giant B, and this is M. ABM. Isn't this ABM situation? Right? So, can I call this A with its own power, B with its own power, and recall what? No, both M. A, M, B, M. Recall what was behind A. What was behind A? Open it and read. Well, it was A to the 1/3. I'm gonna make this A to the 1/3. What was B? Clear it and read it. A to the 1/5. So I'm going to make this A to the 1/5. Wait a second. I have a power already and there is another power coming up. Then I need a parenthesis. And what's that power? Uncover M, please. That's 15. So this guy is 15. Uncover this one. That's another 15. Please, if there is a double power situation, always use a parenthesis among them. Now, if you have a double power situation, double power, you simply multiply 1/3 and 15. What is 1/3 times 15? Come on. What is 1/3 times 15? How many times 3 goes into 15? 5. How about 1/5 of 15? Cancel 3. Now do rule 1. What is rule 1? Add them. Add the powers. A to the 8. So what's the story we got here? This rule does not only apply to single bases A and B, but if they have powers, you can still pass this 15 to each power. 1/3 times 15, 5. 1/5 times 15, 3, and add them. Okay? So I just tried to create new ideas here, explored this and extended this rule, but again, if you don't like this, do Chris's idea. First add these up. What is 1/3 and 1/5? Unfortunately, they don't have the same denominator. You need to match the denominators by multiplying this one by 5 and this one by 3 and add. This is 15 and 15, common denominator. Top is 1 times 5, 1 times 3 is 3. It's 8/15. So this inside is A to the 8/15. I just add them up. Add the tops up. I actually multiplied them. And then we pass this in by multiplication. And they cancel. And we get the same result. A to the 8 again. Two different ways. Which one you like better? I don't care. But do either one. Alright? Does it make sense? Alright, coming up next. Wow, what a mess. Alright, I like Chris' idea. I see a lot of math here. I'm going to first try to combine them into one. So I will first join these two together. Can I do that? Can I add the tops with rule number 1? Rule 1. It says simply add the tops. 3 and 2/3. Can I add them? Can I add 3 and 2/3 just like it says here? Add them. Can I add the tops and get away with this time? What's the difference? We added here, right? 1/3 and 1/5, we added them. Can I do the same thing and add these two? Yes. Look what it says here. This rule says multiplying like bases. Like bases. Bases must match so we can multiply them. You cannot do rule number 1 here. You need to go with my rule, my way here, this one. There is no other way than distributing this power to each and every term on this question. You cannot combine inside terms. Again, none of these, look, 2PRS, none of them are like base, none. You cannot combine them, so what am I gonna do? I will do this rule. This rule says, I call this a distribution rule. I distribute m to power of everybody I see inside. It says this applies to only 2 terms, but this is actually incorrect. You can do this to 3 terms, 4 terms if you want, A, B, C, D, even 5 terms. No matter how many terms you have inside, you can pass m to each and every one. Okay? So I will pass 3 to first, second, and third terms. Do you agree? Yes, it has to go to 2 as well. 2 is an individual term as well. There are 4 terms here. Multiply. It needs to go everybody. So I get 2, 1 times 3, 3. Next, P minus 1 over 3 times 3. I multiply each power by 3. Okay? That's how you combine double powers. When this 3 moves into every power, it creates double. So let's simplify what's that? Alright, let's simplify some basic things on the spot. Like 3 and 3 cancels and this drops to -1, right? What is 3 times 3? 9. These 2 cancel and it becomes 2. So I reduce this into 2 cubed, p to the -1, r to the 9th, s squared. Is this our final result?
When you square 2 or cube 2?
Yes. You are obligated to compute powers of numbers. 2 cubed can be computed, so you need to multiply. This is 222, 222. You need to multiply 222, which is 8. And then, are we gonna do anything about p to the -1? Yes, we have to flip it. Because they say write the final answer using positive exponents. This is not acceptable. Not acceptable, negative power. How about r to the 9? Are you happy with 9? Yes. R to the 9th. S squared. Are you happy with S squared? Yes. So You can even combine all these by putting 1 under and multiplying out. So it is s times 1 is, I'm sorry, 8 times 1 is 8, r 9th s squared on the top. 1 is just p. So this is the best we can do. Okay? All right. Now a couple more left. All right, back row. It looks like you guys are living in your own world, but are you with me? Are you getting this? All right. I know you're focused on finishing your homework, but if you don't learn these tricks, just going with the solutions from the Connect Mat is not gonna help you. Okay? If I give you different type of questions, if you don't know the tricks, you're gonna get stuck. So pay attention here and join in the discussions and ask questions if you don't miss a spot. All right, what do we do here on the next question? I see a division. I see a power around it, like m. So I have a feeling which one is the best rule here. Division? Yeah, I have some messy stuff on the top and bottom of that division, but which rule this feels like? Yeah, it's rule number 5. It says if you have a power around the quotient, simply pass that power to the top and bottom. That's what I'm gonna do. I'm gonna pass 12 to top like this and bottom. But I have now a double power situation. Power, 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 power. And how do I combine double powers? By, how do I combine them? 1/3 and 12. Do we add them? We already distribute. I mean, what do you mean by distribute? Multiply, right? We multiply -1/3 and 12. So what is -1/3 times 12? Simply cancel these. -4. So the top is -4. The bottom, 3/4 times 12, which is 3, -9. Y to the -9, right? Okay. Now, question. Can I apply this rule here because I have a raised to the m here and another base raised to the n here? Can I combine them by subtraction? Can I? The answer is no, because you can only do that if there is a match in the bases. X and Y are the same. No, and we cannot combine these. So is this our final answer then? If we can't combine them? Yeah, we have to flip these powers. Okay, we have to flip, but how do I do that? This is gonna be 1/x, or in other words, it's gonna go down. The stuff underneath will go up. So y to the -9 goes up as y to the +9. X to the -4 goes. Okay, this is what's going on actually. Technically, I don't want to do it right on the spot. I want to first separate them. I can separate x to the minus 4 and y to the minus 9 like this. Just put one above y and separate it. Just put one under x and separate it. X to the minus 4 over 1, 1 over y to the minus 9. Okay? Now, if you have a negative power, it flips the ratio. So it becomes 1 over x to the 4. But if this is a negative power, so you're going to flip this one as well. So it turns into y to the 9th over 1. And you recombine those, they become y to the 9th, x to the 4th. But from now on, I won't show these steps. I just showed once. From now on, you see a negative power on the numerator or denominator. All you need to do is this. Send them to the opposite sides. This guy goes down, this side goes up. When you do that, they flip the power signs. So y negative 9 becomes positive 9. X to the minus 4 becomes positive 4. This is a very useful trick, okay? When they are alone, you usually put 1 over x to the 4th. But since they are combined, you don't show that 1 over x to the 4th. Okay? Alright, this is it. This is what we are gonna enter here. Fraction first, make y to the 9th x to the 4th. Alright, and our last question. It's pretty much the same question as before, except we have just more mess in the inside. Look, you used to have only 2. Now you have 1, 2, 3 on the top, 1, 2, 3 on the bottom. 6 terms between top and bottom. And even worse, this guy used to be whole number you distributed and turned better. This is not whole number, it's a fraction. But do we care? No. We still pass this to the top and bottom first. Pass it to the top and bottom. So I'm applying rule number 5 here. Rule 5 says pass it to the top, pass it to the bottom, that 1 over 2. So 50 r to the minus 1 s 2 r s minus 7. Each gets 1 over 2 around them. Next, we pass this 1 over 2 further to each and every term. Okay? So we have 50 raised to the power 1 over 2, or minus 1 times 1 over 2 is minus 1 over 2, s 1 over 2, because it has 1. 1 times 1 over 2 is 1 over 2. 2, 1 over 2, r 1 over 2, and s 7 over 2. 7 times 1 over 2, 7 over 2. We multiply when you pass a power to inside, and they create double power 7 and 1 over 2. You multiply them to 7 over 2. Is there a negative sign? Oh yeah, sorry. You're right. This is negative, so it makes negative here. Alright. What do you think the next step is? We will cancel, we will combine like bases. Like bases. How? Now look at this. These are all multiplied. But my question is, can I just regroup them and break it into their own ratios? Look, can I break them like that? Can I? Yes or no? Yes. If, as long as the numerator and denominator terms are all multiplied, yes, you can. There are cases you cannot do this. For example, 2 plus 3, 5 plus 7, 2 times 3, 5 plus 7. Here, operation is addition. Do not even imagine separating this as this. You cannot separate this as 2/5, 3/7. Wrong, because it's addition. But if it is multiplication, yes, you can separate them as 2/5, 3/7. Okay? That's exactly what I'm doing here. I'm separating these into groups. Why? I want you to first take a look at this one and that one. Which rule can help us figure these cases? Which rule in this list? It's 2. Aren't they like base? Look, this base and this base the same with different powers. Different powers m and n. Minus 1 over 2 is m. 1 over 2 is n. This is m. This is n. Different base. So we just need to subtract them. So this guy is r minus 1 over 2 is the m. N is 1 over 2. What we subtract them. We subtract the bottom from the top. Top is minus 1 over 2. Minus 1 over 2. Again. N. M. I do the same thing to this guy. S, S, like terms, M, N. So I subtract M and N. Subtract N. Where is my mistake? Yeah. This N here has already a negative sign right here. This is your n. You take the entire thing and subtract, it's going to turn positive. When you subtract a negative number, it's going to make positive. Okay? So 1 over 2 is m minus, look, it says minus, this is the minus. N is negative 7 over 2. Don't ignore the minus sign. Alright, what is minus 1 over 2 and minus 1 over 2? They have the same denominator, so a common denominator. It is negative 1. Minus half, another minus half. If you have negative halves, you have negative whole, right? So it makes sense. This thing is negative whole. How about this one? 1 over 2 plus 7 over 2 makes 8 over 2, which is 4. Half of 8 is 4. So are we done?
Wouldn't it be easier in the process to flip negative half on the other side so it becomes positive, so you already have a 1?
Which negative?
For R.
For R, you mean this? Oh, yeah, we need to flip the negative sign, right?
But I'm just saying, wouldn't it have been easier to put negative half on the right so that turns positive, so you have 1? Right when you're subtracting half and half, you have negative half minus half.
Okay.
Wouldn't it be easier if you put the negative half on the right so the minus turns positive, so you have 1 already?
Okay, you're saying that instead of subtracting n from n,
Oh, okay. I see what
you're
doing.
doing n minus m. So you cannot change the order. No, it's always top power first minus the bottom power. Okay? We can't change the order. But we can always fix this negative later. You got a negative number, we can fix it as this turns into 1 over r. Right? Is the question over though? No, you need to compute number exponent cases until as best as you can do, okay? Well, you know how to compute 2 squared, right? 2 squared is 2 times 2, 4. How do I compute that? This is no issue, but how do you compute 2 to the 1 half? How do I compute this? Or 50 raised to the power 1 half. I wish these were whole powers, like 3. I would just multiply 53 times itself. I will be done with it. How do I compute these? No, we cannot cancel out these like that. Nope. There is no such rule. Well, can we? Yeah. There is one observation here. You can take this back. Look, if you have two different bases sharing the same power, mm, you can take that m out and divide a and b. So I'm going this way. Do you see that? There is already a shared power here, 1 over 2, 1 over 2 matching. I can put 50 and 2 together and take that power out, back out right here. Can you follow that? Look, you can put this in back in. Whenever you need to, you can take it out back. Now what is 50 over 2? 25. We still have 1 over r and s to the 4 though. By the way, you can combine these as s to the 4 and r. Okay? 1 times s to the 4, r times 1. Are we done? Now you don't have any more of these issues. You have this issue. Can I compute 25 raised to the power 1 over 2? Can I? Go back to yesterday. Have we computed such things yesterday? Like you did 16 1/4. Now you have 25 1/2. What does this rule say? You can make it into prison and compute it. You can make this into prison and compute it, right? What number multiplies itself to 25? 5. Very good. Here it was 2, right? What number multiplies itself 4 times to 16? 2. Now it's 5. There we go. So this thing is, again, 1 over 2 turns into radical with index 2 of 25. What number multiplies itself to 25? That's what the puzzle here is. It's 5 again. So we have here 5 s to the 4th over 4. Can I multiply 5 times this and combine like that? Yes. 5 s to the 4th over r. Wow. This is such a long question. But we pretty much use everything we learned since yesterday, right? Since last time. It's a nice question. Measures a lot of knowledge. Okay? This mess turns into such a beautiful answer. 5s to the 4th over r. 5s raised to the 4 over. Yeah, bad idea. You need to start with this one. Alright? Now the section is over. that doesn't mean we won't be using this. No, we will keep using all this. Trust me. This will show up in your college algebra, these tricks. So go practice. Don't just solve these questions once. Once you solve it, you got full credit. Then go hit the practice button and practice more about this. When you hit solve it, it's gonna flip the question. So go solve a different type. See until you get really fast and comfortable. If you don't have any questions, we are starting a new section. Anything? Alright, then we are starting 10.3. Actually, you know what? I want to leave this to Monday. Instead, what do you want? What do you want to do in the remaining 10 minutes? I'm going to show you two options. First one, the one we recently did. You pass this to the top and bottom, and on the top you pass this to each and every power, and on the bottom you pass this power to each and every power. This is what we did in the previous question, and it was a little bit long. Minus 2 times 1 over 3, z times 1 over 3, and 2 times 1 over 3, and w times 1 over 3, and minus 8 over 3, z. And then we group these two together, this two together, and that two together, and we subtracted the powers. You subtract the power, bottom one from the top, bottom one from the top, and we got the right answer that way. It's quite challenging this time because the results are so ugly. 1 over 3 minus 8 over 3. I mean, these are so terrible to add. So my recommendation is go back up. No, don't rush to pass this in. Keep this 1 over 3 outside. Wait a minute, let's say. Wait. It's gonna wait its turn. Why don't you guys first separate the terms in the inside into 3 groups and simplify them first. Perform operation among them first, simplify, then pass 1 over 3. Because 1 over 3 is so ugly to pass, I will keep it waiting. Such as, what is 54 over 2? Isn't it 27? How about w minus 2, w1? How do you combine it? What is the rule? What is that? Here. W squared and w, you just subtract 2 and 1. W2 minus 1. Okay. Here you go. We need to subtract that. So it's 27. We subtract the bottom from the top and we get minus 1, right? 2 minus 1 is minus 1. Agree? Wrong. Minus 2 minus 1 is minus 3. Alright, what is 1 minus minus 9? I'm sorry, 1 minus minus 8. Minus 7, right? Nope, be careful. 1 minus minus 8. It's positive 9. Look how beautiful inside is now to pass this 1 over 3. Okay, so the second method is superior than the first one. First clean up mess inside, then pass the power in. We'll get 27 raised to the power 1 over 3. W minus 3 times 1 over 3. Z to the 9 times 1 over 3. And we all multiply these. Multiply, multiply, and this doesn't need multiplication. Okay? So this becomes minus 3 times 3, 1 over 3 is, becomes minus 1. 9 times 1 over 3 is, well, how did she get this answer? I got totally different. Who's right? Yeah, we first need to get rid of the negative 1 by putting this 1 over W. Okay, that's that part, I got it. But how did she get 3 in the answer? Yeah, we need to compute this thing by prison story, right? 1 over 3 means prison guard is 327 in. What number multiplies itself to 27 3 times? Oh, there you go. She found it like that. Then we combine all these 3 together by multiplying out. And 3z cubed over W is the answer. You like the second one maybe better? Yeah, we got our lesson. First, too messy inside, clean it up if possible. Then pass the power inside.
Can you scroll down?
Alright, we'll see you next time with simplifying radicals 10.3.